Hello everyone, welcome to my channel. Today we are going to discuss about Kubernetes. Especially we will talk about the basics of AKS, and going forward I will be explaining about all the operations that happen inside AKS. So without wasting any time, let's go to the presentation mode. These will be the agenda: introduction, fundamentals of Docker, evolution of Kubernetes, component of Kubernetes, and AKS. So before going to the Kubernetes, we need to talk about Docker and container. Okay, so without Docker and container, we cannot have a picture of AKS Kubernetes. So what is Docker and container? So Docker as a technology is both a packaging format and a container runtime. Okay, so it it will be it can run on most of the Linux, Windows, and Mac OS operating system. So basically, Docker in a layman language, you can consider it as a platform where it provides the container to run. Okay, it has a Docker engine which does all the work of running the containers. And what are containers? The container include the app and all of its dependency and share the kernel with other containers. So as you can see, these app1, app2, and app3 are the containers. So these are running in the same operating system and using the same Docker engine. Okay, and containers, the uh, the good part of the containers is they include the binaries and the libraries, and specifically all the dependencies of that application. Okay, and it bundles those dependency along with the application. As it shares the same operating system, so it is very lightweight, and also it runs as an isolated process on the host operating system. So before Docker and container, we were having some when we were deploying the applications. So we have to pass it through like different environments like dev, UAT, and prod. So some of the applications was working fine on dev and not in UAT. Then it's working fine on UAT and not in production. So why was that those things happening? Because of the environmental discrepancies. So environments were not able to include the dependencies of the applications. So so now, after the arrival of Docker container, as container is having all the dependencies of that application, so that particular issue has been resolved. Okay, so if you are using container for the deployment of your application, then you won't be having the environmental discrepancies. Okay, let's move ahead. This is a basic architecture of Docker. So it has mainly three components: client, host, and registry. So before talking about these things, let's talk about the images first. So images are kind of template, and it contains a set of instructions for creating a container. So without the images, you won't be able to create the container. Okay, out of the image, you will be having the container. So in the client, you will run all the Docker commands. Okay, from the client, it will go to the Docker host where the Docker daemon is present, and Docker daemon is like a brain behind it, is like an engine. So it will process everything, it will take that request, and it will act accordingly as per the instructions that you provided in the client. Now Docker daemon will have to pull an image. So from where it will be pulling? It will be pulling from the registry. So registry can either be public or private. In private registry, like if you're talking about cloud, in Azure you have Azure Container Registry, and mostly you will be using the private registry. Okay, in the live environment. Public registry where anyone can go and log in and pull the images from there and create a container out of it. Okay, so public registry is Docker Hub. You can create an account in Docker Hub and you can pull the images from there. Okay, so images, out of image you will be creating the container. Moving ahead, evolution of Kubernetes. So it builds upon the success of Docker container revolution, and there are two major software development evolution that enable the popularity of Kubernetes. One is DevOps and another one is microservices. So I believe everyone would know about DevOps. So we'll talk about the microservices. So before microservices, we today also we have monolithic applications. So monolithic applications are like the heavy applications, which is very hard to migrate to and to upgrade some of the part of that application. Okay, so if you want to upgrade some of its part, you will have to upgrade all the application. Okay, so let's take an example of Amazon or Flipkart. So whenever you log into that, you get the women section, men's section, kids section over there. Now if you want to upgrade the men's section and you are using monolithic application, then you'll have to upgrade a whole application along with the men's section. But if you are using microservices, then you have to upgrade the men's section only and put it back into its place. Okay, so that has been made easy. Along with that, when you migrate your monolithic application, it requires lots of efforts to do that. Okay, but in terms of microservices, you just need to it won't take much time, and it is very easy as well because the application is uh, uh, break broken down into smaller pieces. Okay, so moving ahead, now let's talk about Kubernetes. Kubernetes, it is an open source system for automating deployment, scaling, management of containerized applications. Okay, so you see, it is basically for the containerized applications. So as we discussed in the previous slide about the microservices, so suppose for one application you have hundred of microservices, hundred of containers. So who will manage it? So Kubernetes will manage it, and that's why it is called as a container orchestrator. Okay, as we know, it has a large, rapidly growing ecosystem. Firstly, it was created by Google. It is written in Go language, and then it is handed over to the CNCF. Let's talk about the features. It takes care of scaling and failover up the application, provides deployment pattern, container orchestration, deployment and replication of containers. So when you are deploying a container, you will have the option to create the replica of the container as well. So if one application is down, if one container is down, the other will be there to serve the traffic. Okay, so uh, it will be uh, it will be used as a high availability. Okay, you can automate the rollouts and rollbacks. So if you want to upgrade, you can do it easily. You can automate it, and if you don't like the upgrade, you can roll back easily. Self healing. Self healing is like one of the best part of Kubernetes, because what happens is when a container is not working as it should, and it is in inactive state, then Kubernetes will automatically try to restart it. It will try to heal it, and if it works, well and good. Otherwise, we will have to intervene. But first step will be done by Kubernetes itself. Okay, secret and configuration management. So secrets are like sensitive information that you key passwords and keys and all those tokens you can put in Kubernetes, and you can attach those secrets with the applications, with the containers as well. Okay, and it integrates with DevOps. So pods. So before going to the architecture of the Kubernetes and its components, we will talk about pod, because this term I will be using. Um, I'll be using very much in the coming slides. So pods, you can consider pods as a inside pod you will have the container. So pod will be bundling that container. The containers will be bundled inside pod, and inside pod you can have one or more than one container. Ideally, we should have one container, but yeah, I have seen in my experience, mostly if we are using more than one container, then only two containers will be there inside a pod, not more than that. Okay, and it will share the same storage and same network resources. All the containers inside that pod. Each pod is assigned a unique IP. Okay, and each pod can have multiple replicas that we discussed in our previous slide. Yeah. So there are two types of node. One is master node and another one is worker node. So master node is also called a control plane. It manages, plans, schedule, monitor nodes. Which node? The worker nodes. Okay, worker node where your actual application is present. Okay, so master node is like a brain behind Kubernetes, and all the operations will be done from there. All the instructions will be passed from master node to the worker node. Okay. Okay. Now, where Azure Kubernetes services play here? Now, this is a fully managed Kubernetes service offering from Microsoft. So Microsoft has, like Microsoft is offering everything, like all the components inside the master node. The master node completely is managed by Microsoft. We don't have to take care of it. If something is not working, Microsoft will take care of it. Okay, and we have the Microsoft support option if we need extra help. The control plane is managed by Microsoft. Nodes are managed by customers. So only we have to manage the worker nodes where the applications are present. Okay. So along with Azure, you will have most of the resources that you can use in your Kubernetes, like networking, authentication, RBAC, volume, backup mechanism, um, and all those things. Also, it can integrate with ACR, as we discussed that in Docker registry has two types of registry. One is public and private. So ACR is one of the private registry. You can use it as a private registry, and where you will be storing the images. And when you are creating a pod where container is present, you will be pulling the image from the ACR, because without image we cannot create a container. Okay. So masternode components, although we are not controlling it, we are not monitoring it, but still we should know about the components of it, because it will help you to understand the architecture and the working workflow of the cluster, of the Kubernetes cluster. So first will be etcd. It stores information in a key value store. So it is a kind of database of the Kubernetes. Everything, all the operations that you will do in the Kubernetes cluster will be updated in the etcd. Okay. Kube API server, so it will be the first component that will receive your request. So Kube API server will receive your request. If you want to deploy a pod, it will be taken by Kube API first, and then it will go ahead. And it is the only component which talks with etcd. So whatever information, whatever request you are putting to the cluster, it will be taken by Kube API server, and it will be stored in Kube API server will be storing that information into the etcd. Okay. Now Kube controller manager, it watches the status of the pods. So if one pod, it will try to match the active state versus desired state. What is that? So let's suppose you have created a pod, and you have the option of putting the replica as well, as we discussed earlier. So let's suppose you put a replica as 3. So 3 pods for the same application will be running will be running every time. Now sometime something happens to one of the pod, and it is not working, behaving as it should, and it has gone to the inactive state. Now controller manager will see that, and see that the active state is not matched with the desired state. Then it will pass that information to Kube API server, and then Kube API server will take that request and update the etcd. It will check whether the in that the etcd, inside the etcd, the active state is different, right? And then it will process the request. It will process the like it will create one more pod. Kube controller manager will not create the pod. It will just inform the API that it is that something is wrong. Okay. And then API will take that request. Now scheduler will schedule the pod to the active node. Just remember, it just schedules the pod. It doesn't create the pod. Okay. So it will schedule the pod to the active node. Okay. If you put a request of creating a pod, then it will go from the API to the scheduler, and scheduler will schedule the pod to the active node. Now the worker node components, kubelet. Now as we discussed that the scheduler will schedule the pod, then who will create the pod? Now kubelet will be the component that will create that pod. Okay, and it also monitors the nodes as well, the worker nodes, not the control plane node, not the master node. Okay, by the way, control plane and master node both are same. Okay, don't get confused on that. Kubeproxy, it manages the network configuration in the cluster. So that if one pod tries to talk with the another pod in the same node, and if one pod tries to talk with the pod in another node, so those things will be managed by the kubeproxy. Now container runtime. So container runtime is a software that is responsible for running containers. Now when we were talking about Docker containers, where the containers were running in the Docker, right? So Docker is a type of container runtime. If I'll go to the previous slides, where it is. So here we discussed that container, it is a runtime, container runtime, right? So container runtime is a software that is responsible for running the containers. Okay. Now after 1.22 version of AKS, Docker is not used as a container runtime. Container D is another type of container runtime that is being used. Okay. So there are a lot other types of container runtime. Rocket is also one of them. um, I guess Rocket is there. I'm not sure on that, but yeah, there are different types of container runtime. So and all of uh, they are doing the same work, like responsible for running the containers. So yeah, now container D is being used. Services. Services is an abstract way to expose an application. Okay, as a network service. So the pods, the applications you are creating in the container is running inside a pod, and pod is placed inside a node. Okay, now pod needs to talk to the outside world, right? So who will do that? So services will help in exposing your pod to the outside world. So there are different types of services that we will go through in our coming videos, but for now, uh, so just understand the services it is being used to expose your pod to the outside world. Now this is the architecture of the Kubernetes cluster. We have in the left hand side, we have the control plane, the master node. In the right hand side, we have the worker nodes, which is customer managed, okay, which we will manage. Now one user has placed a request of deploying a pod. So that request will go from the API server. That request will be taken by the API server. API server will update the etcd that this request has been placed. Etcd will register it. Then from API server, it will go to the scheduler. Scheduler will schedule the pod to the active node. It will check which node is active and which node is in healthy state. Okay, so that it will do, and it will schedule that pod to the active node. Now from the active node, the kubelet will take that request, and it will ask the container runtime, which is container D, to create the container. And from where the container will get created? From the images. And where the images are stored? In the ACR. So container will be created, image will be pulled from the ACR, and the container will get created. Now all these informations, that the name of the pod, name of the application, uh, place of the image, so all these things we will be placing in the pod YAML file. Okay, so in the coming videos, in the next video, we will discuss about the deployment of a particular pod, and also creation of the AKS cluster. Okay, so that's it for today's video. Hope you Hope you liked that. Hope you it was beneficial for you, and uh, just stay in touch with us so that we will be covering and we will be covering all the operations that will be happening inside Kubernetes.